associate editor for peer-reviewed journal. He is motivated to improve occupational health to US research, teaching, and service. And for this, he has received the Rising Star Award from International Textile and Apparel Association. Uh, your research work is really inspiring and motivating us all. I always try to refer your papers whenever I'm talking to students. So over to you, sir. Thank you so much for your time.
Yeah. Thank you. Thanks for the nice introduction. And everybody can hear me, right? I'm audible,
Yes, you can hear.
right? Okay. Okay. I'm sharing now the presentation. Yeah. So, good morning, everybody. And thanks for inviting me to present on the Flash Fire Protective Performance of Textiles. My name is Sumit Mandal. I'm an associate professor in the Oklahoma State University. So when I talk about the Oklahoma State University, it is the Department of Design and Merchandising. That's my department. It is established in 1900. It's one of the top 15 design institute over there in US, and it has our research focus is mostly related to the functional textiles for apparel and interior furnishing, personal protective equipment, functional design. We also have the other sector where they focus on the fashion business, interior design for large buildings and nursing home, apartment buildings. Those are our goal. But functional textiles is one of the key goal there. Our department has about 7 US patent on that protective clothing, equipment, and all this stuff. Our student populations is more than 300 in our department only in the design and merchandising. We have more than 12 tenure track faculty. Those are contributing in all of this research area there. So I'm Sumit, and I actually did my bachelor degree from India. Then my master's is from Hong Kong, and also I did a small degree from Nottingham Trent. My PhD is from textile apparel science from University of Alberta, and I was postdoc at the Swiss Federal Laboratory IMPA in Switzerland there. So everywhere it's mostly the background is related to the textile technology, textile science. There, last 14 years I'm doing the teaching, research, and supervisions experience in India, Hong Kong, Canada, Switzerland, and joined OSU in fall 2019 there. So this is my fifth year at OSU. My teaching and research interest is mostly textile protection, fire protective textiles, and also the fundamental textile science technology. And it is mostly related to the textile testing and quality control there. So when we talk about our research and our focus is that in our research group, mostly that I lead here, that is mostly to study the interaction between human beings, textiles and clothing and their nearby hazardous environment. So if I put it in a diagram, it looks like that this is the center of that human beings, and it is covered by the textiles and clothing. We all wear the textiles and clothing there. So there could be the nearby hazardous environment, that could be the natural hazards like heavy rain, snow, earthquake, disaster, or it could be that occupational hazards. Occupational hazards could be the fire, heat, hot water, steam. There are many different kind of occupational hazards there. So in our research group, we generally this is the kind of our pictorial diagram of our research that we focus on, depending upon the hazards and whatever person is there to give the protection to the human beings. And also our main goal is also to give the human comfort, because protection is definitely which is very important, but comfort is also connected with the protection there. So our objectives for today's lecture, that is on fire protective clothing. So we'll try to understand that, understand the flash fire protective clothing from the perspective of textile material, and then we will understand the thermal protective and comfort performance of protective clothing from the perspective of textile testing, modeling, and in consideration with the heat flux sensor. So as considering that it is a training workshop, so I'm not giving only the academic aspects, I am also giving some practical aspects in this lecture so that everybody could get benefit out of it. So when we talk about that, why we need to think about this research? I still remember that when I was doing my master degree in Hong Kong, I was thinking that how I could give the human protection through my textile knowledge. And then when I was investigating, this is one of the graph I'd like to present. If you see that the number of firefighter injuries in United States, every year it's about still Still now in 2022, we got about 65,000 firefighter injuries. And also over the year, the injuries has been declined, but still the 65,000 firefighter injuries is quite a lot for the US. And also, if we see that the number of firefighter death every year on duty firefighter death is about 1996. So this is really, really very high. Some years like 2001, it's about 443 firefighter died, and this is the 9/11 year. So we just 2 days back, we celebrated the 9/11 days. And on the same day, about 400 firefighters died on the same day. So the kind of job they are doing, it is very, very important for the human beings. So that's why in our research group, we are motivated to talk and give them the safety. And this is our goal as from the university, to help the community and give them the good research so that they could get the benefit. A similar kind of statistics that is applicable in other countries. Not much government statistics are available at this moment. For examples like that, many Asian countries where we really cannot find the data sets for each and every year, how many firefighters got injured, how many firefighters died. But it is quite common that all of this one is nearly similar in every country. It is a big problem. But and firefighter turnout gear, if you see here in the picture, that is the turnout gear, looks like that could mitigate the firefighter injuries and death. When we really talk about the fire protective clothing, firefighter turnout gear is that one kind of the gear that actually helps to get the protection from many different types of hazards. That's why I chose this one. So I am asking you one question, is that share your experience and thought when you watch this video, and share with me that what will be the requirement of a good quality firefighter turnout gear. I could see that many people are here online. They could give some replies there.
Welcome back. They run into burning.
So please watch this video first and try to understand that how firefighter work and what will be their requirement for their clothing, that is the turnout gear.
Buildings pry injured people from damaged cars. They could even help restart your heart.
Fighting fires is only part of the job for the men and women of Toronto Fire Services. Today, Chelsea Agro strapped on the 60+ pounds of gear they wear to get a first-hand experience.
High heat and cutting hoses. From tall buildings to tight, smoke-filled spaces. There isn't anywhere you won't find Toronto firefighters.
It's basically anything that comes up that another service isn't going to do, we're there to look after it.
Long before the work begins, you have to suit up.
This is the fun part, okay?
Your breathing apparatus is the most important piece of equipment.
One ensemble is about close to 60 pounds.
Really? This fast?
Yep.
First, we need a lesson in life-saving. Continuous compressions are now the norm when it comes to CPR.
One of the young lads missed, and he ended up coming down on a wrought iron fence.
We also meet the impalement unit that specializes in unusual rescues following unfortunate accidents.
They call it the thinking truck.
The thinking truck. The hazmat unit is one of the city's most specialized. Just last week, they visited a Scotiabank exec who opened an envelope.
Inside there was nothing except for white powder.
Outside, our first exercise is an extraction.
This is called the spreader. Jaws of Life is the nickname.
Powerful tools these crews use regularly on our roads. Going into burning buildings is also routine. Crawling in the dark and across flames is commonplace. Firefighting, we learn, is a team sport. Taking down this tanker fire takes time. So does sorting out how to handle the hose and its nozzle. Hot places like this car fire are all about technique. Spraying first from afar, then zeroing in on the engine to knock it down. This is pretty high.
Well, it's all relative, I guess.
7 stories up, aerial operator Jeff Richardson feels right at home.
Can go up and down so we can go over wires and get into places.
A window into a hard day's work, which is a way of life for a very select few. Charles Siagro, CBC News, Toronto.
So I have a quick questions to all. Anybody like to share anything that what will be the requirement for a firefighter gear? Let's see. Anybody have any thought on it? Anybody like to share
I think
something?
the training is really
Yeah.
important on how to use everything, not only the kits, but also the other equipment, and most importantly in a team, one person do it all.
Yeah. So we'll see in a moment on that. And from there, thanks for that one. It is not only about the fire. There are many other equipments and also other things they need to handle. I will gradually discuss about that. So when we talk about that firefighter turnout gear, this is the jacket and pants that is commonly used in United States, but many other countries, they also use those kind of clothing. Only things is that in other countries, depending upon the weather or climate, it could be little bit lightweight, but in US, the firefighter clothing is really very heavyweight because we always believe that protection is the most important parameters there. At the same time, when somebody is wearing the heavy clothing, that means it becomes the comfort. That is also another issue. So when we talk about the protection, that is not only the thermal protection, it is protection from the sharp object, protection from many other different aspects there. It is involved. But all the protection and comfort together is the most important requirement for firefighter turnout gear. And when we talk about this and considering the current scope of the presentations, if we only see about the thermal protection, so for turnout gear, it is not only the protection from the huge flame that you have seen. It could be that a good amount of hot surfaces because they need to crawl to the hot surfaces. There is flame, there is radiation, there is hot steam, there is hot water. All of those parameters are actually involved for the firefighter protection. And also in recent years, that's why I mentioned about the 9/11. After 9/11, the another parameters like the chemical, biological, radiological, nuclear, all different kind of protection becomes very important for firefighter. And when we talk about the turnout gear for firefighter comfort, if you see that this is the, imagine that this is the firefighter. So when we talk about this comfort, and turnout gear should exert the low weight. And as I told you in a moment, in US, that firefighter turnout gear is heavy, and many countries, the turnout gear are heavy. And it is actually required that they should transfer the metabolic heat, they should transfer the liquid sweat, liquid vapor, sweat vapor, all these things are very important. So when we are talking about the testing of firefighter gear, we all need to think about all these aspects related to the protection and comfort. And here I'm not going to focus much, but because it is everybody possibly know in this platform that the fiber is definitely very important. And yarn, I know that Dr. Kumar's organizations is developing quite a lot of yarns and fabrics on that side for the gloves material. They are doing quite well on this side. So every time there are new fibers are coming, those are really high performance fiber, and people are trying to develop the yarn that could give their really better protection, that could really give the good strength to the materials. And also some people use the natural fiber. In that case, they take the natural fiber and they give the fire retardant coating, and they try to use. But if you see that in the firefighter gear at this moment, most of that material is about the synthetic fiber. So when we talk about the synthetic fibers, there the commonly used synthetic fiber in firefighter turnout gear, you see that across the world, those are the kind of materials people use very commonly. But those are not the only materials. At least I've seen about the 10 to 12 different kind of fiber materials people are using it every time to develop the firefighter turnout gear. Those are doing good as well. Some fiber are really very common in United States. Some fibers are very common in European market, but those are nearly having the similar properties. One of that common properties that is about related to the strength and related to that its thermal protections on that side. That is mainly related to the melting. Here I would like to say that definitely fiber is very important, but how we weave the fabric, how we design the clothing, all those parameters actually affect the firefighter protection. It is not only about the knowledge related to the fiber. Yarn, fabric, all are very important in this case. Those fibers are people commonly use because of that no thermoplasticity, and also having the good tensile strength, the couple of benzene rings, double bonds, everything's are there. So those are very strong there. But only the strong fiber cannot give the good protection to the firefighter. It requires insulation. Insulation from the thermal hazards is very important. So when we talk about the fabrics for firefighter turnout gear, most of the time we use the multiple different layers of fabric. So when we see that one, the fabric one is that a cell fabric, which is commonly the oven fabric, people use it there. That is one type of fabric. Another one, as you have seen that quite a lot of water moisture people use. So the laminated fabric that is called as a moisture barrier that people use. Also there are thermal liner, and thermal liner, which is really very, very thick at this moment. People are trying to definitely make the thinner non-oven thermal liner so that it has the higher thermal insulation. So now when we have all those combinations of the fabric, so what should be that right combinations? You could combine it from many different organizations, but it is not possible to use in any combinations. You have to use with certain combinations. So if you see that turnout gear outside to the inside on firefighter skin, it is mostly that A, which is that first outer layer you have the oven fabric, then you have the laminated moisture barrier, and then you have the thermal liner that is actually in contact with the human skin. So those are actually kind of fabrics there. So you see that the different types of fabrics people use it, and also the properties of their insulation, how they give the insulation to the human beings. That is very, very important there. So when you use it in these combinations, the outer layer actually faces the hazards. It has very high strength for the integrity Long time back, people even see that whole garment actually burned there. So nowadays we have very high quality fiber. They have the high strength and integrity they maintain there because of their melting temperature, glass transition temperatures, those are very high. People also have the laminated fabric that is used in the middle layer that protect from the water steam, and also they have the non-woven layer in that provides as a thermal insulations to the human beings. So when you have all these fabric and there, now it is the most important part is about the testing of the firefighter turnout gear. When we talk about the testing of firefighter turnout gear, there are definitely the first degree bench scale test, which is the small fabric size. That small fabric size you could use and do the testing. In our lab, also we generally called it as a first degree test, which is very small bench scale test. There is possible also that the second degree, where people still use the fabric and do that complex bench scale test, where they put the fabric little bit larger than the fabric used in the bench scale test. So, but it is still the small fabric size they use. And of course, there are full scale mannequin test. That's the turnout gear, the whole turnout gear you could use. So you see that the from first degree test to the second degree and third degree full scale mannequin test, everything is possible there. But why we need to do this one and how we will do this? One of the important parameters is that to measure the protective performance by heat flux sensor. So here, if you see that I tried to put this one, each and every panel there is sensor. If you see this mannequin, the whole mannequin having the sensor. I will show you this one very much that how many sensors people use it. And what we actually get the protective performance in terms of second degree or third degree burn time or percentage. Here you see that when the burn occurs, when we give the hazards there, and in case of mannequins, even how much percentage of burn occurred on the human body, that also we can calculate there. But one of the important part for all these measurements is all about the sensor. And sensor is one of the my favorite study area where I try to use the sensors. Those sensors are actually like the simulating the human skin. At this moment, there are 4 different types of sensor. I will talk about this. The number one that came there on that thermal sensor, or it called the embedded sensor, somebody called the epoxy resin sensors. It is actually the DuPont sensor. So DuPont in their test, DuPont is that the company the largely manufacture that protective clothing, protective gear there. They use this kind of sensor. It is the thermoset polymer, and it has that nearly this type of the length and diameter. So thermocouple is there, and it measures the heat flux in this one, because heat flux is that most important parameter when it exposed to the thermal hazards, how much heat flux is there. And from that heat flux, they try to calculate the second degree burn time. If you want to know more about those sensors, you could actually read our publications. In our publications, we talk about those sensors very much in details about their properties and their structures, everything there. Now, when we talk about the thermal sensors, other types, that is the copper sensor, that is the thermal protective purpose. Somebody says it TPP sensor, thermal protective performance sensor. That is kind of ASTM or NIST, National Institute of Standard Technology there. They also talk about this sensor. They recommend this sensor. So at this moment, if you are following the ASTM standard to measure the protective performance, most of the time people use the copper sensors there. So this is the copper sensor. It looks like that. you see that in comparison to the previous sensors, the thickness is lower. It has a different diameter, different kind of thermocouples is there. So it is different. But in that case, both the cases or all the cases, most of the time, they measure the heat flux. Heat flux is very important for our research area, and especially those who are doing the work on the thermal protective performance. So they are also in our thermal sensor publications at this moment. If you are, this is the sensors, Thermetrics is the company. They largely manufacture these sensors, and they provide these sensors. They are, some of the Thermetrics team also talked with me. Hopefully, they planned to attend this uh, workshop or this presentation. I don't know, but the Thermetrics is that a company. They largely produce this. Every university is also there in some cases having the different sensor. This is the North Carolina State University. They use the pyrocal sensor. Pyrocal sensor is their kind of a modified copper sensor in this one. So they are still using the copper disc, but as you know that copper causes the lot of heat loss that even we see in our laboratory. We use quite a lot of copper sensor. There we see that copper loses the heat. So they put the copper sensors in an insulating block so that heat sunk tube is there, so that copper sensor is not losing any heat. So it is more accurate heat flux calculation. So you see that there is a little bit of the air gap, tight air gap, causing the insulation so that copper is not losing the heat there. This is the modifications they did about their sensors, and it is also in our publications. You could see in details if you ever read those publications. And this is the sensor that's called the skin simulant sensor. It is from University of Alberta, Canada, from where I did my PhD. They use it quite a lot. It looks like somewhere like this skin simulant sensor. In the previous cases, you have seen that people are using epoxy resin, people are using copper, most of the time insulating copper. But University of Alberta, that sensor is about it has the material that called the color serum. It has the different kind of minerals and everything. It's as a thermocouple that is attached on the surface, type T thermocouple, and it's also the length and diameter is very different there. So it is also in our publications at this moment. You could read it. So as of now, I discussed about the 4 different type of sensor that could be used to evaluate the protective performance of the fabric and clothing. That is very important for us. There is no good sensor or bad sensor at this moment. Important is that if we are using this sensor, all these 4 sensors are actually recommended by ASTM in their mannequin test. So you can use any of these sensors. That's not a problem. Only things is that when we are using this sensor, we have to consistently use those data. It is really not so much possible to compare the data from one sensor to the other sensors always. So there is no good bad sensor. Only things is that which sensors you are using to develop or test the protective clothing. So as I worked with the University of Alberta skin simulant sensor that I commonly used in many cases, now I am using copper sensor. I also have the skin simulant sensor, but most of the time the principle is actually to calculate the heat flux on this one, because all of these sensors actually somehow worked in the model, especially the skin simulant sensor. Based on this skin model where you have the thermal exposure, then your skin has been divided in this way: epidermis, dermis, and subcutaneous. So your sensors also having that kind of thickness, it has been described there. And so you could measure the heat flux at the different layer. And then one of that common software they use, that is the Hendrik Burn integral software. It's probably possibly about the mid of 19th century. It has been developed, but still people use it because it measures the temperature at the epidermis skin depth and for time for which the temperature is about 44 degrees centigrade. So after 44 degrees centigrade, our skin started to burn. There it could generate the first degree burn, second degree burn accordingly on this one. So if you ever do this test, most of the time you have the sensor. From the sensor, you get the heat flux. Then your sensor has to be coupled with the software. That software can measure the second degree burn time. That I told in the beginning. It measures the burn injury parameters for the clothing. So the time for at which that this omega value reaches to 1, that is the T is equal to 44 degrees centigrade in equation 2, that is called the second degree burn time. Remember that the first degree burn, it could occur, especially like in India or somewhere, if the temperature is very high during the hot summer, people are coming outside from outside, they could see that their skin is red color. It could be a chance of that little bit of first degree burn, not so much dangerous. People could take the good bath or something. But second degree burn is that the first stage of that burn where it is very dangerous to the human skin. That's why most of the time we try to measure the second degree burn time, because after that is the third degree burn is very bad and fourth degree burn worst, because it damages the human tissue, bones, everything for that. And so this is the Hendrik Burn integral software. There is another one that is software based on the Stoll curve. That is only applicable to the copper sensor. We cannot use the Stoll curve in multiple different other area. Stoll is that the name of the researcher. When she did the research, she actually gave the exposure for different amount of time, and for a particular heat flux, she tried to calculate when the second degree burn occur. And then when we use the copper sensor, we see that how the temperature rise is occurring. So when our temperature rise curve matches with that copper sensor or the Stoll curve there, this particular point, we called it the time for second degree burn. So for example, if we go down from this point, we can actually calculate the second degree burn for that any clothing when we put it there. When I will show you the test, that will be more visible for this one. So required heat flux for certain exposure time to generate the second degree burn. It has been developed also long time back, but still we are using it in our study, so that we could get the calculations of the second degree burn time. And this one has been recommended by many, most of the standard recommended about this Stoll curve and their injuries protection. We also talked about it in details in our book about the Stoll criteria, about the Hendrik Burn integral criteria. Everything is there, so you could see it. Now, when we are talking about the first degree test, I talked with you about this one, the first degree, second degree, and third degree. So let's discuss about a little bit first degree bench scale test, how it occurs. So there are thermal protective performance tester. You see this one, where it is under flame and radiant heat. It could go up to 80 kilowatt per meter square. Most of the test actually, and all of these sensor actually could resist the heat flux up to 100. So, and our standard test we recommend, or any of the standard test we carry out, which is about 80 kilowatt per meter square, we choose that. And radiant heat protective performance tester is there. I know Dr. Kumar's lab, There are a few testers like this where you can measure the radiant heat protective performance test. There is hot steam and hot liquids plus or immerse tester. Although there is no ASTM standard, but there is Canadian standard in this area. So people use it quite a lot. Even though all of these test standard are there, I still like to mention that cone calorimeter. Cone calorimeter is not related to the thermal protective performance of that product of our textile material, but cone calorimeter could give quite a lot of properties like that: how much heat has been released by the material, how much smoke has been generated, what will be the time of ignition. All those parameters we could actually get it from the cone calorimeter. There is also arc flash fire hazards, especially for the electrical worker. Nowadays, it's a big challenge. So arc flash hazard, it is also 80 kilowatt per meter square they do. So when we check this one, I just trying to show you a video on that one, how it occurs. So you see that it is that kind of the stole curve that I have shown it to you. We could get it through the stole software, and we could measure the heat flux accordingly on that. So there are a lot of standard. There are standard available, American standard, Canadian standard. I know today, late today, there is a presentation organized by Dr. Kumar on that team is about the standard, related different standard and how it is gives the protection and comfort to the firefighter or any other workers. Now the second degree bench scale test that we talked here on this one, this is one of our in our publications. So we actually developed when I was doing my postdoc at EMPA. We developed kind of hexagonal panel. If you see that there are quite a lot of burner. So instead of using the human mannequin, it is actually the hexagonal sensor, and each panel having about 6 sensors. And so we put it over the fabric on that, and then we expose it to the fire hazards, and then it could give, we could calculate that how much will be the burn injury on the top side or bottom side depending upon the flash fire hazards. This is in our publications, and you could read it if you want. There you will be able to see this second degree complex bench scale test and how we did it. And now the third degree full scale mannequin test. And this is the full scale mannequin, how it looks like there. So in that mannequin, there are different kind of flame that get exposed to that. And then I'll show you a video how the people do this mannequin test everywhere.
ASTM F1930, more commonly referred to as the mannequin test. This test method is designed to evaluate the protective performance of material when exposed to simulated flash fire in laboratory conditions. The test is performed using an exposure heat flux of 2 calories per square centimeter per second for 3 seconds of exposure time. Here's how the test works. The mannequin has over 100 heat sensors distributed uniformly around its body. The mannequin is surrounded by at least 8 propane burners. In order to test a fabric, you need to create a coverall out of the material being tested and wash it once. The standard actually outlines the size and design of the coverall and how it is to be washed. You put this onto the mannequin over a set of 100% cotton t-shirt and briefs. So, you have the mannequin dressed, and then a simulated flash fire is initiated. The burners are lit and project flames onto the coverall for 3 seconds. During the fire exposure, the heat transmitted through the material is measured by those 100+ sensors. Using this collected data, a calculation is made that is used to predict the degree of second and third degree burn injury. Let's see what this looks like. As you can see, the mannequin is totally engulfed in flames for the entire 3 seconds. But once the flames go out, you see the FR coverall has not ignited and does not continue to burn like a comparable non-FR version would. Here is an example of the 3 different burns on the mannequin. Here, you have percentage of body burn, for example, 20% or 40%. And along the bottom is how long the test is run.
So you see that this is the kind of the test method recommended by the ASTM, and people follow that. Mannequins are available available mostly at this moment in the standing posture, but there are also movable one. I will show you in a moment. So mannequins mostly developed in DuPont. They have their own mannequin, that is the thermoman. They use their own sensors to to evaluate the protective performance. North Carolina State University, they have their own sensors and they use those sensors to evaluate the protective performance. And in Impa, Switzerland, they also have their mannequin similar to the thermoman they have, and they evaluate the protective performance. So they are University of Alberta, Canada. Those all mannequins having a name, very nice name. You could see that they called it thermoman, some called it pyroman, and in Alberta it's the Harry Burns. Harry was very good friend of mine when I used to work there for PhD. Very nice guy actually, and evaluate the protective performance. Here, if you see that latest side or innovations on this area, I will show you a small video. Actually, one of the thermetrics people shared this with me. So so you saw that one. It's another kind of the new areas that is. Sorry for that. And so it is one of the areas that is coming movable one. In our publications, you will be able to read all of this one in our ResearchGate, all these publications related to those mannequins and their structure. It has been written quite well on that one. You could read about that. So protective performance testing in our laboratory, we try to do this one in our laboratory. There are different facilities there in this website. You could find it. We also have a big fire department, fire engineering department. We work with them close together. So that department actually have almost all kind of fire related testing, but those are mainly the material testing, not the mannequin, but those are mainly the material properties we evaluate. So in our lab, we mainly follow the American standard, Canadian standard, some cases the British standard or ISO standard. At this moment, our current research area, we are mostly focusing on that oil and gas. As we are in Oklahoma, we have the huge oil industries in and around Oklahoma, Texas, that area. So as we always work for the community, so in that case, our research goal is to help the industry there. So in that oil industry, that mostly they have the contaminated textile fabric. So as of now, whenever we discussed, we are mainly talking about the new fresh clothing. But when somebody is working in the industry, their fabric get contaminated. So when we use this contaminated fabric and we try to do that test, it is completely a different phenomenon. So you see that in this test, we have contaminated the fabric with the oil, because when the oil workers work in the factory, their fabric or clothing get contaminated. So we do this one. And recent years, cancer is a big problem. So we are now switching from our burn injuries towards the cancer prevention among the firefighter, oil and firefighter, oil and gas industry workers. So fire protective clothing, how it could also give the protection from polycyclic aromatic hydrocarbons, that's the cancerous substances that we get. So we try to do this one. In our other side, as I told, that we also do the bioburden analysis, especially after the COVID. We try to do the some test related to the bioburden related to the microorganisms on that clothing, especially in that those who use it in the daycare, adult care center. They are more vulnerable to these substances. So we check also those. We have that equipment related to this. So you could get some ideas about those research even in our publications in the research gate. As I always say that the protection is a big issue there, but also the comfort, thermal comfort is more another more important issues that we need to consider. We cannot only consider the protection. So when we see about this one, there is in the comfort related area, there is also that first degree bench scale test that by ASTM. There is intermediate state test that is in the ISO standard. There they take the little bit of larger amount of fabric in comparison to the small scale bench scale one. There is also that full scale mannequin test where it is the mannequin test. They have the mannequin and they do the test. And also we have that option for human trial that we do quite a lot with our kinesiology department, human physiology department. We do there. It could actually give the real human data about the comfort performance of the clothing. So what we measure for comfort performance, we mainly measure the comfort performance by temperature and vapor sensor. So it has been a thermocouple and also the vapor sensor to measure the thermal resistance and evaporative resistance of the clothing, that we mostly measure there. Mannequins, they are great for they have the different postures, they are moving at this moment. Those are mainly developed. There are a lot of universities they develop very old one on that time, not so much technologically advanced. That's the Finland mannequin. It called Coppelius. In Hong Kong, they developed Hong Kong Polytechnic University. They developed one mannequin that is the Walter mannequin. Those are the name of the mannequins there. In Impa, Switzerland, there is a mannequin that's the Sam. His name, it has been used there. Thermetrics, that's the company I always say. They have their mannequin on that time. They came with a mannequin, name is Newton. And it has been, about the generations of the mannequin is also changing. Now the mannequins are very advanced. Those are mannequins came in the early stages there, and then the Newton got married and they got the Mrs. Newton, which is Thermetrics, and they also have the baby now. So it's in the different places. They have the baby mannequin. It could be useful to check the baby's thermal physiology for different. Of course, they are not going for firefighting, but you could check their physiology by using those mannequins. mannequins has been used in many different places there. Now I'll show you a latest mannequin that came with the thermetrics. It's a good one. We have that also. We are collaborating with the other universities to use that. One of the universities have at this moment here, actually two, I think, have this. So this is another next generation mannequin. Very recently came. His name is Andy. Andy mannequins people are using to measure the heat stroke. Very much applicable, definitely for firefighter, and also some countries, India, where the heat stroke could be a big problem. So people could use it and check their clothing performance by using that. In our laboratory, we also have few of this equipment, but mostly the bench scale at this moment. We are planning for a ND mannequin now. And we mainly check the oil field workers clothing drying performance, the moisture management and low stress mechanical properties of oil field workers, also the wildland firefighter. At this moment, we are mainly focusing on the wildland firefighting and oil and gas field workers clothing and their properties and all this stuff. We publish our work in many different areas. So mannequins are really revolutionary for technology in textile testing. It has been used several times. It's a group of researchers. They use it for many different purposes.
Thank you, Professor Anthony. Is there any question? I can see few questions in the message segment. I think we have launched it. Let me just check. I think we have lost it. Let me just try to we wait for just some more time. I think yeah, he's back. Professor Sumit, can you hear us?
Can you hear me now? Can you hear
Yes.
me?
Yes, we can hear you.
Okay. Sorry, technology and that. Yeah, so in this slide, I talked with you about that mannequin and that video. You can see it in that YouTube, that a revolutionary technology about the textile testing, how people did it. This is our research group. We publish quite a lot every time related to the textiles, related to the mannequins, related to the fire testing. So, but our goal is mostly to about the textile protective performance that we do. This is our team members. We have the PhD student, master student. We can make the collaborations with the different universities and department so that we could use their equipment. We could do the testings there. So we also graduated few students in recently in last 4 years. There are some companies, they give us the funding to conduct the research. Big support we get it from Oklahoma State University there. So they give us the support to do the research, and also the different other organizations, they also give us the support to conduct the research. This is in this link there you can actually get the informations about our PhD program, our the master's program. If anybody is interested on that one, they can actually contact the program coordinator or contact to me. I will forward that applications to the department, and we can definitely work on that one. We have the huge positions open at this moment. We have the funding. We would like to recruit the students there. With the IT team in future, we like really interested to make the collaborations. If ITT, we discuss sometime for especially for the material development, innovations, modifications. So that kind of parameters we really want to focus on the nanomaterials, nano substrate. We are working on that side to make a lightweight clothing. That is our focus there. Yeah. Any questions, anybody? I'll be happy to answer that.
Thank you so much, Dr. Sumit. Really wonderful session. And I think I can see a few questions in the chat box. Maybe we can take this one question.
Yeah.
I think Mr. Abhijit wanted to know which sensor you can use for EN407 gloves testing.
Sorry, I cannot hear. Can you repeat the question?
mentioned that he'd like to know which sensor do you suggest to use for EN407 glove checking.
Oh, no, it is that as I always mention that the sensor, it is very difficult to say that which sensor, but I always suggest that if you choose one sensor, please do continue with that sensor and make the data sets based on that sensor, because here it is very difficult to get the actual value of that second degree burn time there. So it is mostly for the comparison purpose. So any sensors that you could use, copper sensor, good. It has been recommended by most of the standards. So copper sensor will be the good one to use it there. And it is easily available. Rest of the sensors is mostly manufactured by the particular university or particular organizations, may not be available so much. So copper sensor will be the good option.
Thank you. And one question is, if we collect data with epoxy sensor, can we use Stoll curve? I believe you have answered that, the Stoll curve is not suitable for epoxy sensor.
No. The Stoll curve has been only applicable for the copper sensor.
I can see Dr. Krishnan Roy sir wants to ask a question. Krishnan sir, please go ahead. Krishnan sir, can you hear us? Yeah, please ask your question.
Sir, may I?
Yeah.
Yeah.
Yes,
Good
please,
morning.
go ahead.
First of all, thank you so much, Mandal sir, for your excellent presentation. I just had one question, sir. Is there any correlation between the Stoll curve, the kind of data which we get from the Stoll curve, and when we do a 3D thing which you mentioned, the mannequin thing? Is there any kind of extrapolation or any kind of correlation between the two?
Yeah. So one thing here we have to understand that properties. So it is not about the sensor, because that sensor, for example, you are using the bench scale test by using the sensor, and you are using the same sensor for the mannequin test, and you want to know that correlation, right?
Yes, sir. Yes, sir.
Okay. Yeah.
If there is any.
Yeah. So in that case, remember that the bench scale test only applicable for the material properties. It has nothing to do with the other related to the garment design. So when you use the mannequin, it is not only the material properties, it also having the garment having trapping air between the body, the microclimate, air, and all those parameters actually affect the second degree burn. In the bench scale test, you can create that air gap, but that is not at all correlated with the human body, how, or mannequin body, how it generates the air gap. So people are trying to make a correlations. There will be need a requirement, but it is definitely not a linear correlations. We have seen several times that it is possible to find a correlation factor by using that, but it is not a linear correlation.
Okay. Thank you so much, sir. Thank you.
Any questions from audience? I just have one question. When we talked about this cancer issue, and even I was reading one article. So, what update we have on because of this breathable membrane? Can we correlate that because of this breathable membranes, toxic gases are going inside? And can we say that, or it's too early to put all blame on breathable membrane? I'm talking about firefighter suits.
Yeah. You know that the breathable membrane always having a coating, that is the PFAS coating. It's a fluorine carbonated fluorine materials, and forever chemical is there. So whether it is burning or not burning, it has a chemical that is cancerous. And recently the firefighter organizations or International Firefighters Association, they recommended that the using the PFAS free, you know that in the moisture barrier, that coating, that is actually the fluorine coating. That it's similar like your fry pan, where you use the Teflon coating. It is the similar one. So it itself cancerous. And when it get burned, it again causes the cancerous and toxic one. Only things is that we use the moisture barrier in the middle layer. So it does not get burned very easily. But if it burns, all of those materials, if it burns, it create the toxic gases. In our research, we have a deposit, we have burned the material, we deposit it in the fabric, deposited on the human skin. We have seen that there are toxic PAH materials. That's the polycyclic aromatic hydrocarbon, cancerous material. Definitely it is there. And I just like to mention here that the recent trend is to get the PFAS free materials, especially for firefight. Does it make
Thank you.
sense?
I mean, yeah, perfect. Thank you. And on your last few slides where you mentioned, we are also very keen on, our strength is we can develop a lot of yarns, we can develop a lot of fabric, knitted, woven, even non-woven I'm trying to set up. But the limitation what we get on the testing side. So we are very keen on, working with you where we can characterize some of our materials and, we can come up with work.
It is,
So
yeah,
that,
we will be definitely can work on this one. And it is not only about the testing, it is also about that why that material is behaving like this under that testing condition. So material characterizations is the best or biggest part, so that you could develop the new material by considering those properties. Yeah.
Sir,
if
I am
there is
Suryakant.
one more query, and then Mr.
Sir,
Please go on.
sir, I am Suryakant. Thank you very much, Sumit sir, for the nice presentation. I have two. I need two clarification. First one is regarding the calculation of burn injury. We are calculating burn injury from the flux value. Can calculate the burn injury from the direct temperature data, because all sensors giving the temperature data, not exactly flux data. First, they are giving flux sensor is giving temperature, then we are converting flux, and then we are calculating the burn injury. So can we calculate burn injury from the direct temperature data? First
Yeah.
query. And second
No.
query is the calibration of sensor. So please brief about how we can calibrate the sensor. What is the procedure?
Okay. Okay,
Thank you.
good. Good. Thanks, Suryakant. Very nice questions. I'll be happy to reply on that one. The biggest challenge at this moment to get the temperature and correlate it with the directly to the second degree burn time is that challenging to get a material that is exactly like the human skin. The sensors that we discussed, those have the properties of the human skin, but they are not exactly the human skin. And second things is that remember that human skin, in that all those sensors, if you give the heat, they don't degrade. But if you in the original situation, if your skin get the heat, skin also change the properties. So we definitely need a material that is actually simulating the similar all the properties, and having that a kind of the in the skin also have the blood vessels and all this stuff. So it is a great innovations. It will be that when we have a real skin like materials substances, and we put the thermocouple exactly on the epidermis or dermis depending upon that skin layer, then it will be possible. I know recently somebody contacted us, and he is developing a kind of sensor where it is actually the temperature could be calculated, but that materials having that property of the skin. That means also that when it is getting the heat, we need to actually discard that because it may get damaged. So it is your first questions, right, Suryakant?
Sir, actually, suppose we are using a skin simulant sensor,
Yeah.
and again, skin simulant sensor also giving the temperature data, and may this temperature data we can use the calculation of burn injury.
Yeah, here we are getting that temperature data direct. You know that we are getting the temperature increase with the time, and then from temperature is increase, we are calculating the heat flux, because that heat flux is required also for our Stoll curve to get the second degree burn. Or Henry equation. Otherwise, we cannot use that.
That's why I'm asking, sir. So from the Henry by the Henry equation, shall we calculate the burn injury prediction from the temperature data, or we always need the flux data?
We need that flux data from there on this one. And also, if you see that there is, if you go to there, let me go back. Can you see my screen?
Yeah.
Yes, sir.
Yeah. So if you see there, it is also that the temperature, epidermis skin depth. Can you see that?
Yes, sir.
Yeah. So if you have a real skin-like materials, we can definitely use it in that way.
Sir,
Otherwise,
I
it's
think
not that
the general question which he wants to put is that a skin simulant sensor is being exposed to heat, certain heat flux. We are generating the temperature from there. We're using it to calculate the heat flux and then do the burn injury calculations. His basic question is that since it is basically the temperature which we are getting, can't we directly use, because it's a skin simulant sensor? That is basically his question.
No, I don't. I have not seen in that way.
Okay, sir. Okay.
So we have not seen in that way. That is the temperature, and then in the finite element method, they use in that sensor. They see the temperature rise, then they get the heat flux, and then they use it to calculate the parameters there.
Okay, sir. Thank you, sir.
But I know few people are working in this area. The new materials possibly will come soon there.
Well, again, the question was important, how to calibrate these sensors.
Yeah, so calibration
Can you
is,
help us on that?
yeah, for the calibration is mostly it is required to use the niched sensor. That is the water cooled sensor. Water cooled sensor is that the recommendations by niched, that is the sensor they use. So we put the niched sensor there to check the heat flux, and then we put the naked sensor on the top of that heat flux, top of that fire. Then if it is the correlation we found, that means it is calibrated. So for the calibration, we need a niched sensor. That is the water cooled sensor or Gordon sensor.
So,
There.
apart from the NIST sensor, sir, shall we calibrate the radiant heat source or from the flux heat source?
That's the radiant source. Radiant source. If it is the water cooled, that is mainly for the radiant heat source.
So what are the process for the calibration, sir, for the radiant heat source? How
Yeah, so you create the radiant heat, then you put the niched sensor on that, you check the data, and then you put your sensor, whatever you are using, and then you check the data.
So, Sally, you have, sir, the flux pattern or temperature pattern for the calibration for any sensor you have,
Yeah.
sir?
Yeah. So copper sensors, and we in our lab we have the niched sensor as well, and then we check it with the radiant heat, and then we put the other sensor there, and then we check the radiant heat through that. If it is the calculating in the similar or we get the same, heat flux on that time, we don't use any fabric material.
Okay, sir.
Does it
Thank you.
make? Yeah. So it is the procedure about the calibrations also written in all the standard of ASTM.
Okay, sir. Thank you.
Thank you, sir. Just one last
Yeah, so I want to ask the performance specifications, like when we can say the second DD one or third DD one to on the years we are doing testing. The
Sorry,
performance
I can.
specification of how
Sorry,
we
I
define
cannot.
that the second DD one will occur. Sir, I want to ask how we will define that the second DD one or third DD one will occur, depending on the performance results we are getting from the test. Means what percentage of years you're getting, that how much heat loss is there.
Sorry, lot of echo. I can hear only up to second degree burn. Can anybody explain? Yeah. 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 Can you repeat the question? Could you please? Could you please? I cannot hear anything.
I think that he wants to know the performance specification to check second and third degree burn. So I think that will depend on the standard, which standard we are following, like ASTM F1930. So ASTM F1930, that's what I'm concerned there.
Yeah.
So what are the test performance years? We define that second DD one will occur or not occur. Third DD one will occur or not occur. For ASTM F1930 standard.
That's the mannequin standard, you say, but right?
Yes, sir.
That is the mannequin standard. And in that one, your question is that why we need to calculate second degree or third degree or what?
So he wants to know how we can quantify. I think that will depend on percentage burn injury, whatever is acceptable. Example, in India, we try to keep it less than 15% total burn injury. So that will depend on the percentage, what is acceptable.
Yeah. Oh, you mean that the testing of that one and the acceptance range?
Correct. What's there in US and how much is acceptable and what's in Europe? Or no, is it same throughout the world or it varies from country to country?
Yeah. It is same throughout the world. I cannot tell you the exact value now, but it is you can check the NFPA 1971. NFPA 1971 and NFPA 1977 is the pass-fail standard. So when you have a material, those two standards actually could give the values for the material about the second degree burn and third degree burn, how much it will be the acceptable or how much it will be not the acceptable there. So it was about 15% on that injuries, but recently they are changing some values, but it is written in the NFPA 1971. If you are talking about the pass-fail, NFPA standard has to follow, and those countries which follow the NFPA standard, those have the same requirement. And I think most of the cases it follows the NFPA standard.
Thank you so much. And with this, we'll this session. Very thank you. Yeah, quickly we can take a group photo. If everyone can switch on the camera, then we can just take a quick group photograph. Thank you. Thank you so much once again.
Thank you. Thanks. Bye.
Have a nice weekend.
Thank you, sir. Thank you.
Thank you. Bye.
Bye.